Another rationalist of this modern period was a fellow by the name of Gottfried Leibniz. He was born 1646 and lived into the early 18th century. Leibniz is known for many discoveries, among which are the binary code, which of course is the basis of our computers these days, as well as calculus. Here we have an invention of his, it's called a reckoner, which calculates numbers using binary code. And he cites how he was able to discover binary code. Yes, yes, no, no, yes, no. Here we see a famous discovery he made of the calculation of pi. This is the infinite series that he discovers, and the image says it. Two mathematicians, James Gregory and Gottfried Leibniz, each working independently of one another, discover an infinite series for arctan, that is 1 over 10, in 1670s. This arctangent series led to the first ever found infinite series for pi. Here is the arctangent series they discovered, and for clarity it can be written as follows. And by expanding this series to an arbitrary number of terms, we approximate any arctangent to arbitrary precision. This was the calculation of that ubiquitous term pi. He also discovered the area under varying forms of curves known as differential calculus. The metaphysics that Leibniz wrote is what we'll focus on today, and his work is called the Monadology. Now, not one substance like Spinoza, nor two substances like Descartes, but many substances, according to Leibniz, account for the nature of reality. He was dissatisfied with Descartes because having only two produced the dilemma of how they interact. And he was very dissatisfied with Spinoza because reducing everything to one substance loses the distinction between the various elements in nature. He also rejected the materialist notion of atoms as the primary substance. What he said was that monads were the simplest substance. Now, what exactly are monads? And we think of these as force or energy. He called them as metaphysical points, which did not have length, breadth, or height. They were metaphysical points of energy. Now, he did say that they possess minute perception. How interesting. The most basic unit of reality has perception, but it is not this kind of perception that we have, which is very complex. It is a simple on-off switch. It's almost as if he's talking about cyberspace. He says that monads resemble the idea of physical particles, but they are not. And they are independent of one another. They are different from one another. He calls them windowless, and he says they do not influence one another. So it's like this being in a tiny little cubicle and not being influenced by anything around you. He does say that there is a pre-established harmony, and the separate purposes of each of these monads form a larger scale harmony. What he means is that each individual monad has in it the whole. So here is one interpretation. It's called the holographic model. The whole is reflected in each monad. It says, metaphysically, all properties of monads are internal or innate, but many exist as expressions of relations to other monads. This is one interpretation of what it might be like to be a monad. And here's another. They were found behind a pile of dirty socks. As you can see, Leibniz's claim for the existence of monads has come under a great deal of attack and skepticism. But he does say that God's existence is evident because the harmony that we see is pointing to the existence of God. God stands outside the infinite series of contingent possibilities. He is the author. And we might think of it like this, that the contingent possibilities are infinite possibility of space and infinite possibility of time. And if we have spatial temporal perception moment to moment, God is the author of all the possibilities of spatial temporal existence. Because God is a good God, the spatial temporal reality that we have is the best of all possible worlds. This has also come under attack. It's hard sometimes to imagine the world we live in as being the best of all possible worlds. What does he say about knowledge? Well, this is truly the important considerations for the work of Leibniz in the area of logic. He talks about two different kinds of knowledge. There is the analytical knowledge, which is true by definition, and that would be all bachelors are married men, for example. That is true by definition. Their opposites are self-contradiction, and they cannot be false. You're either a bachelor or you're not a bachelor. And it's not possible, if you're a bachelor, to be anything other than an unmarried man, because it's true by definition. And we know these things without experience. The truth of them is independent of any observation. Now, synthetic truths are not true by definition. The truth or falsity of these kinds of statements depend not only on the meaning, but also the facts in the world. The door is open. Now, it has to be the case that somewhere in the world the door is open. And it means also that the synthetic truths are contingent. They could be false if the facts were different. Let's say the door was closed. Well, to say the door is open would be false, because the fact is the door is not open. This is called a posteriori truth, and the truth or falsity is known by observation.